this is Team LEM. I'm Sai.
My name's Rohan.
And so our project is we are aiming to provide like a solar panel that that has like one major degree of freedom. It's like to rotate this way, and it's also like self cleaning. So how it aims to do this is we have servo motors attached, so it can rotate this way. We also have pulleys that cause like the brush to go back and forth periodically.
And so basically what allows the panel to tilt is the light sensors on either side of the panel. So basically the light sensors are connected to the breadboard, and the battery over here powers everything here, including the motors, the Arduino, and the light sensors.
And so basically we have resistors connected to the photoresistors in series, which which are then connected to the Arduino's ground, and all the motors are connected to this mini breadboard right here, which is then connected back to the Arduino in like the digital outputs in either side of the Arduino.
Hello, this is Anthony from FSE LEM, and I'll be explaining the Arduino code for our prototype. So up here at the very top, we have all the variables I use in the code. Light A is the variable for the amount of light, the amount of units of light that the photoresist will be measuring in. So light A and light B are all doubles. And then for the double X, the variable double of X, it's X will represent the angle, how much the servo motor will tilt, and I'll explain that later as we get to it in the code. And then integer Y, we're setting it to 0 because it's kind of our timer to dictate when the two DC motors will turn, because they control our cleaning mechanism. Then we just call these two servo motors positive and reverse, but shorthanded. Now in the setup, we have pin numbers 7 and 6, and those will be connected to our two servo motors. So Arduino will send a signal to tell them to turn on and stuff. And then for analog 1 and 2, they're both connected to our two photoresistors. And they'll tell the Arduino the amount of light at that moment when we tell it to. And then for pin mode 2 and 3, we have them connected to one motor, one DC motor, so we can control it, dictate when it's turned, and the same case is for 4 and 5, which is hooked up to one DC motor. Then we attached for 7, we just say the servo motor will see the signal from pin 7, and it will also receive it from pin 6, respectively. And then for serial begin of 9600, it just allows the serial monitor to pop up so we can like actually see the values. Now onto the loops. So we define light A as equal to the amount of light reading from analog 1, which is this light sensor right here, light A. Then light B is the amount of light which is being picked up by light B, the photoresistor V. And then essentially this code allows us to print the value of the amount of light that each photoresistor is picking up respectively. Then these three if statements essentially allow us to tell the servo motor how much to tilt, and I'll go into detail. So what we did is that if light A has a greater value of light being shined on it, this if statement will execute, and we define the amount of angle it will tilt from the difference of light A and light B. So we're using the difference of the amount of light being picked up, and we're dividing it over light A, and essentially that becomes our angle, and that's how we calculate. It'll give us an angle. Then we'll just tell the respective motors to move, the servo motors to tilt by 90 minus 45 times the x value, which is calculated above. And we'll do that for the positive and the reverse motor. And we'll also print it onto the serial monitor. And then we'll delay it. And then we'll increment y by 1. And this essentially y increases from 0 to 1 once, and it'll increase so on as long as each if statement is executed. And then I'll explain what happens when what we do with y later. Second if statement is what happens if they both equal each other, so the amount of light on each side our prototype is the same, it won't essentially it won't tilt. It'll just stay at a 90-degree angle, which is our default angle. And then we'll tack on y plus 1. I mean y will increase by 1. And then the last case is what happens if light A is less than light B. We'll essentially do the same, but except this time it's light B, as the initial thing was subtracting light A from light B, and light B becomes the denominator in our factor for changing the angle. Then we multiply 45 degrees by our angle found for one motor, and then for reverse motor we do 45 times x as well, but except we're subtracting it from 90. And we'll also print and delay and then increment the variable y up by 1. And now what we do with y is since y will determine when the cleaning mechanism actually activates, essentially when it hits 600, it's not exactly seconds, but it's 600 increments. And once that happens, we just tell one motor to turn on, twist one way, the other one is also off, so it's only one working at a time. And then we delay, and then it just stops. And then once y hits 1200 increments, the other motor will turn on. So it'll turn on and pull it to the other side of the solar panel, and then it'll stop after 1000 milliseconds, and then it'll reset y equals to 0.